Hey, physics, let's take a quick look at some of the crazy things you might have to do with a free fall problem. Let's say your buddy throws his physics book down off the top of, the View downtown. That's 12 stories. Okay. Sorry, it's just View. It's not the View. So, friend throws physics book down from View. All right. Let's say the book has a mass of 2 kilograms. Let's say they throw it down with a speed of 10 meters per second. So that's going to be a velocity of negative 10 meters per second. That's how fast it's going when it leaves your hand. Let's change that. Let's make that negative 5 meters per second is how fast they throw it. And if it's free fall, it's only subject to the force of gravity. So if I've got this 2 kilogram object here, I'm going to have this downward force Fg. I get by taking m times g. So 2 kilograms times 10 newtons per kilogram, and that works out to be 20 newtons. It's the only force in town. So my Fu equals 20 newtons. And then my acceleration is going to be Fu divided by m. So 20 newtons divided by the mass, 2 kilograms. That works out to be 10 newtons per kilogram. So 10 meters per second squared. Those things are equivalent units. You knew that was going to happen, though, and that's directed downward. So when I go to draw a velocity versus time graph here, where do I start this? Well, here I told you, it's thrown down. It starts out already going negative 5 meters per second. The acceleration is 10 meters per second squared directed down. So that's going to go like that, okay? And I could ask you to find things like how long does it take to hit the ground? It's a 12-story building, figure 4 meters per story, so we're talking, 48 meters? The change in position, which maybe we call it delta y because this thing is falling, would be yf minus yo. That would be, that's not right, buddy. Yf, it's going to end up at ground level. Yo would be 48. So the delta y is negative 48, and that would be the area here. I'm just talking about the change in position. It's delta y because it's vertical. So this is negative 48 meters. My slope here is negative 10 meters per second squared. And I want to figure out how much time does this take. So let's change colors here. So what is t? Well, again, you can kind of see how this ends up being a rectangle and a triangle. And the negative 48 meters will equal the area of the rectangle. That's going to be this, plus the area of the triangle, and that's this bit. Let's use our slope understanding again here. This triangle has a slope of negative 10, so if this is t, then this dimension is negative 10t. Okay, I didn't scale this thing very carefully. So anyways, the area of the rectangle, that's going to be, it's negative 5 meters per second on that side, and then this dimension of the rectangle would be t, plus the area of the triangle. The triangle, similarly, well, let's see, make sure it's a triangle, so I better put that 1/2 in there. Base of the triangle is t, and the height of the triangle is negative 10t. Okay, so I'm multiplying those together, base times height. So negative 5t plus 1/2 of negative 10t squared. And so I've got negative 5t minus 5t squared equals negative 48 over here. And unfortunately, I hate to spoil it for you, but there's no real clean way to get out of this thing without rearranging it, adding 48 to both sides, kind of rearranging terms, negative 5t squared minus 5t plus 48 equals 0. That's in the form 0 equals ax squared plus bx plus c. So a is negative 5, b also negative 5, and c is 48. And now you hit up your dear friend opposite of b, plus or minus square root of b squared minus 4ac, and that's all over 2a. So find the solutions to that, and those are your possible values for the time it takes for this thing to hit the ground. Should only be one of them that makes sense, and then you can go back in there. And then once you got that, you can figure out how fast this thing is going over here. But my pen's dead, so I'm going to take that as a hint to call it a night. All right, good luck.